Review for Module 13 on absolute value and piecewise functions. Number 1. We need to distribute the negative 2 with the x squared. That becomes negative 2x squared. Negative times a negative is a positive, and 2 times 1 is 2, so positive 2. And then that's where the distribution ends. Then we bring down the negative 5x at the end of the expression. If you look at the problem, none of these are the same type of term, so none of them are like terms. This is an x squared, that's an x, and this has no variable at all. So if we put them in order from largest to smallest, or in this descending order, we start with the x squared, which is this one, and then the x, which is the negative 5x, and then the one without the variable, so 2. So it goes 2, 1x, 2x's, 1x, and no x's. On B, the problem number B, 1b, we have like terms. So after distributing, we get 12x and then minus 48, and then there is no distribution here, so just plus 5x and minus 48. We see that the 12x and the plus 5x are actually like terms, so we get 17x. And the negative 48 and the negative 48 are also like terms, so when you add those, you get negative 96. On C, 5x and negative 6x are like terms. The 10 and the negative 2 are like terms, and the 8y and the 4y are like terms, and none of them needed to be distributed. So 5 minus 6 is negative x, 10 minus 2 is positive 8, and 8y and 4y is positive 12y. On D, the negative 7x and the negative 10x are both like terms. That's this negative 17x. And the negative 4x and the 6 become positive 2x. And then there's the negative 9. After putting them in order from largest to smallest, descending order, x squared, x, and then no x's at all. Solving an equation. We're going to add 4 to get rid of the negative 4. And what we do to one side, you do to the other. Negative 10 and 4 is negative 6. And bring down your 2/5. In order to get rid of this fraction, you're going to need to multiply by 5, but divide by 2. So that's why we're doing the reciprocal, 5 over 2. And what you do to one side, you do to the other. So we're going to put times 5 over 2 on this side. The 5's will cancel, the 2's will cancel, leaving us with x. And over here, negative 6 times 5 is negative 30, and 1 times 2 is 2. So, and negative 30 divided by 2 is negative 15. That's what our x value is. Problem C. 3 times 4 is 12, and divided by 2. Or we could do 3 halves times 4, and the 2 goes into the 4 twice, and 2 times 3 is 6. We could multiply the 3 times the 8, that's 24, and divided by 2, we get 12 right here. Or we could multiply the 3 halves times the 8, put it right next to the number, and 2 goes into 8 4 times, and 4 times 3 is 12. And then over here there was no fraction, so it's just negative 6. Now we're going to add 12 to both sides. We're going to get 6x equals 6, because 12 minus 6 is 6. Divide both sides by 6, and the 6's cancel here, leaving us with x, and 6 divided by 6 is 1. Problem D, 4 times 3 is 12, 4 times 2 is 8, 4 times x is 4x, and 4 times negative 6 is negative 24. Move the negative 4x to this side, so opposite of 4x is subtract 4x on both sides. We get 8x minus 8 equals negative 24. Now add the 8, and that's 8x equals negative 16. Divide by 8 on both sides, x is equal to negative 2. Out of problem number 3 and problem number 4, I'm deciding to do number 4. So on problem number 4, 2 times 5 is 10. And if you divide by 5, you get negative 2 because of the negative. Here's negative 2x. 2 2 times 10 is 20, and if you divide by 5, it's -4. There's no x's there. When you distribute, there are no x's. Then you have your less than or equal to. Then you have your 3x plus 6. We're subtracting 3 from both sides. That'll give us -5x here, and -4, and less than or equal to, and the 6. Now we're going to add 4 to both sides. We end up with -5x and -5, and 6 plus 4 is 10. We're going to divide by -5 to cancel the -5, and what you do to one side, you do to the other, so we're dividing by 5 here too. The -5's cancel, and here we get -2, but main thing is that this inequality needs to change directions. The reason why is because here we're dividing by a negative. Anytime on an inequality, when you divide by a negative number, the inequality needs to change directions. So you can tell here that it's switched. That means I'm going to have an open circle at -2. Here we go. Excuse me, closed circle because of the line. Closed circle at -2. And we move to the right because this is greater than. Number 5, you can see here that this, the first part is a function because it only crosses with the vertical line test once. But part B is not a function because you can see that this vertical line crosses twice through 2 different points, one here and one here. So one input can only map to one output. That concludes page 1. On page 2, we're dealing with discrete and continuous. Now, if you remember, if you cannot cut something in half, then that means our problem is continuous. But if you can, if you cannot cut things in half, it's discrete because, for example, a bag of chips. I can't go to the store and ask for a half. That's going to be discrete. I'm either going to get one whole one or I'm not. Okay, and then when I can cut things in half, like money, for example, I could cut $1 in half, or I can cut it into pieces, and that's going to be continuous. So on A, you can see that it has to do with money and the amount of money in your bank over time. Actually, I think that's continuous, but they put discrete here. So part B, the grade on a test based on the number of problems correct. That's going to be discrete because it depends on how many problems you get to correct. So you're counting. So 1, 2, 3, 4. I'm getting 5 problems correct. So that's discrete. Part C, the height of the tree over time, because it's going to grow and there's going to be decimals as it's growing. Could be growing 1.5 inches, 1.5, 1.7, 1.8 inches. So that's going to be continuous. The amount of profit made from each car sold is going to be discrete because it's a certain amount you're making, and the next time you're going to get a different amount. The number of songs each student has on their iPod. Remember, you're counting. So I have 10 songs on my iPod. I have 11 songs on my iPod. But you can't have half a song. And same with D. In D, I can't sell half a car. So that's why it's discrete. I either sell a whole car or I don't. The number of cans collected for recycling. Discrete. I'm going to count the number of cans I have. The distance that a car is traveling. That's going to be continuous because it doesn't have to do with the car itself. How many cars. It's just going to be the distance. So I can go 1.5 miles. I could go 1.8 miles. Number 7. I need to solve for y because they're telling me to solve for y here. So to get y alone, it's being multiplied by 2. I'm going to divide by 2. I'm going to divide by 2. I'm going to divide by 2. This will cancel, leaving me with y. This does not cancel, but it's okay. I'm going to leave it as 3 over 2x. And 2 divided by 2 becomes 1. So plus 1. On B, so I'm going to move the 3x to the other side. So I'm going to need to subtract 3x. And when I subtract 3x, it cannot be added together with the 15 because this has an x and this term does not have an x. So I'm going to have to write them separately. So as you can see, I brought down the -5y. You bring down the -3x, and then you have a positive 15, so plus 15. Now I'm going to need to get the y to be alone. So it's been multiplied by a -5. Opposite of multiplying is dividing by a -5. What you do to one side, you do to the other side, to all the terms. So these will cancel, leaving me with y. The -3 and the -5 will become a positive because a negative divided by a negative cancels out and becomes 3/5 x. And then now 15 divided by -5, when I have opposite signs like this, it becomes a negative. And 15 divided by 5 is a 3. So there is my answer for y. On part C, I need to solve this time. They want me to solve for x. So here's x, and it's being multiplied by -4. So all I need to do is do the opposite, which is divide by -4. And I'm going to divide by -4 on the other side as well. These will cancel. The negatives cancel. The 4 cancels, leaving me with the x. The 16 divided by a -4. When these are opposite, the 16 is positive and this one's a negative. It stays a negative. And 16 divided by 4 is 4. And now I have y. A negative and a negative become a positive when I'm dividing. And 8 divided by 4 becomes 2. On part D, they want me to solve for x again. So you can see here that I'm going to move the y to the other side. Since I don't want the y here, I want to solve for the x. So I'm going to bring down my 3x. The y moved to the other side and it cannot be combined with the 6. So I'm going to write them separately. So 4y and 6 is a positive 6. Now I need to remove the 3. So x is being multiplied by 3. Opposite of multiplying by 3 is dividing by 3 to everything. These will cancel, leaving me with x. And 4 divided by 3 does not go in even. So I'm going to leave it 4/3 with the y. And then, but 6 divided by 3 becomes 2. On number 8, I need to solve for the compound inequality. So I'm going to work off the middle and try and remove everything until I have x by itself here. So I'm going to subtract 7. And what I do to this side, I need to do it to the other two sides. So -5 and -7 become -12. I'm going to still have the less than or equal to. I still have the 4x. These cancel. I still have the less than, and 23 minus 7 is 16. Now I'm going to divide everything by 4. So I'm going to end up with -12 divided by 4 is -3. The 4's cancel with the x. The inequalities stay going the same direction. And 16 divided by 4 is 4. And here's my answer. I still need to graph. So because this is in between, I know that I'm going to be here in between. But I'm going to start at -3 with the closed circle because of this bar. And this side is going to be open because it doesn't have the bar. And pretty much here's your graph. Part B is an OR problem, which means they are going to go in different directions. So but first I need to solve it. So I'm going to subtract by 1 on both sides. I end up with -6. 3x, divide by 3 on both sides. And x is less than -2. Or here on this side, I'm going to subtract 7. I end up with 2x is greater than or equal to 8 because 15 minus 7 is 8. Divide by 2 on both sides, the 2's cancel. X is greater than or equal to 4. So here this one is an open circle going to the left, and here this one is a closed circle at 4 going to the right. That's the end of page 2. On number 9, the graph is showing the distance of a car and how much it travels throughout the day. So how does part 1 of the graph compare to part 2? So you can see that in part 1, the car is moving a lot faster because the line is steeper. And in part 2, it's moving a little slower. How does part 8, which is here, differ from part 9? So in part A, the car is coming back, but it's coming back in a slower way because the line is less slanted. In part 9, you can see that it's a lot steeper, it's more slanted, so that means the car is coming back still, but much faster. What is the significance about parts 3, 5, and 7? So if you look at part 3, 5, and 7, the car is not moving. The time is moving, but the car is not moving. And then in part D, what is the difference between part 4 and part 6? If you look at part 4 and part 6, in part 4, the car is moving away, it's moving ahead, and in part 6, the car is coming back. Again, in part 4, it's going faster, but in part 6, it's moving slower. Number 10, they're asking us to list the domain. The domain is all the x's, so -4, -2, 2, 4, and 5. And then you put your braces on both sides. Now list the range, which is the y's. So 3, well, they're going to be out of order. We're going to have to put them in order. But 3, 5, -3, 3, and -1. You can see that the 3 repeats, so I don't have to write it more than once. 3 is fine, only once. And we start with the -3 because that's the smallest one, and then -1. And then the 3's, which we have 2 of them, and then the 5. But you see, we only wrote it once. Is this relation a function? Well, we need to look at the x's and see if any of them are repeating. So you can see this is not the same. And none of the x's are the same. That means, yes, no input, which is the x's, maps to more than one output, which means I cannot have more than one of the same x. On number 11, Tammy has a job at 2 companies. So company number 1 pays her $28,000 plus the $3,000 each year. In company number 2, they pay her a salary of $36,000 plus $2,000 raise every year. Now we don't know how many years she's going to work, but they want us to find out when the salaries are going to be the same and or when the salaries are going to be the same. So we need to set both of these companies equal to each other. So I'm going to subtract by 22,000x on both sides, leaving me with 1,000x. Now I'm going to subtract the 28,000 from both sides, leaving me the 1,000x equals 8,000. I'm going to divide by 1,000 on both sides, and that means that the companies will pay Tammy the same amount in 8 years. And then it says, what will that salary be? So I can take this 8 years, and I can either put it into the purple or I could put it into the pink. So we're choosing to put it into the purple. So we're going to do 28,000 plus 3,000 times x, which is 8. And here it is, 28,000 plus 3,000 times 8. And once we figure that out, we find out that in 8 years, she will be making 52,000 in either company because it's the same in both companies. On number 12, we're listing the domains again, -2, which we don't have to repeat. This one repeats, -1, and then 1, and then 2. Now, we already know that's not a function because the -2's repeated right here. And we cannot have any domain repeating. We cannot have any inputs go to more than one output. So we can see here that the input -2 is going to -1. And this input -2 is also going to 5. Now, we have an input that's going to 2 outputs. That cannot happen. So the list of the range is the -1, and then 3, and then 5, and then 6, and then 7. Now the range is your y's. I just put them in order from smallest to largest. And no, this is not an input function because the input of -2 maps to -1 and to 5, and you don't want that to happen. Okay, Grace bought a car that had 450 miles on it. She drives 35 miles each day. So this is a y equals mx plus b problem. So they want it in function form. And because they said function, I need to say f of d, where d stands for the number of days. So it says write a function that shows the number of miles on Grace's car after d days. So that means they want the x not to be x, but they want it to be a d. Now, how many days is she driving? We don't know. We don't know how many miles she's going to drive in one day. So she drives 35 miles, each day, but we don't know how many days she's going to drive. So 35 miles every day plus the car already had 450 miles on it. So this is our function. Now it says if Grace now has 1,150 miles on her car, then how many days has she been driving? So we're going to take this 1150 and we're going to put it here because we already know how many miles she has at this point. So 1150 equals 35d plus 450. Subtract the 450. And then here, I know you can't see it very well, but we have 700 equals 35d because these canceled. And then you're going to divide both sides. You're going to divide both sides by 35, and d equals 20. And that's the end of page 3. In problem number 14, solve for the equation for y first. So we have our equation here, and we're going to move the negative 2x to the other side. That should go first, and then the positive 6. Divide everything by 3, and we end up with y equals negative 2 over 3x plus 2, because 6 divided by 3 is 2. On the table here, you're going to substitute negative 6. So we're going to put negative 6 here times negative 2/3, and then we're going to add 2. So you can see that the 3 divides into the negative 6 twice. So negative times a negative is a positive 4, plus 2 is 6. The negative 3 and now if we substitute negative 3, so the negative 3, the 3 and the 3 cancel, leaving us with the negative times negative is a positive 2, plus 2 is a 4. If you substitute in 0, then it'll just be 2, because this whole thing will be 0 plus 2, which is 2. And for 3, substitute 3 in. 3 and 3 is cancelled. Negative 2 plus 2 is 0. Substitute in the 6. 3 goes into 6 twice. And 2 times negative 2 is negative 4, plus 2 is negative 2. Graph those points and make your line. Part D, they want to find out the value of y when x is 27. So basically it's like you're plugging in the 27 here into the table. So 27 times negative 2/3 plus 2. The 3 goes into 27 9 times. 9 times negative 2 is negative 18. Plus 2 is negative 16. Number 15. Joy started her day with 15 happy memories. That's what she's starting with. And she makes 3 more happy memories each hour. So 3 times however how many hours she's happy. So happy memories. So function, that's your function. If Joy goes to bed with 90 happy memories, that means this whole thing is 90. And we still have the equals 3h plus 15. We're going to subtract by 15. We want to find out how many hours. So we have 3h equals 75. Divide by 3. That means that Joy will go to bed with 25 happy, if she'll go to bed with 90 happy memories, but that means that she was awake for 25 hours. On problem 16, we're going to solve for y, moving the negative 2x to the other side. Negative 2x goes first, then the 3. And you can use your slope-intercept form to graph. So our y-intercept is 3, starting here. And then we go down 2, right 1. So down 2, right 1, down 2, right 1. And that would be our line. Or you can make a table by substituting in negative 2. Negative 2 times negative 2 is 4. 4 plus 3 is 7. Negative 1 and negative 2 is a 2. 2 plus 3 is 5. 0, this whole thing will be 0, plus 3 is 3. 1 times negative 2 is negative 2, so basically 3 minus 2 is 1. And 2 times negative 2 is negative 4, so 3 minus 4 is negative 1. Same points, you graph them, and there's your line. Number 17 is already in slope-intercept form, so we can start with our y-intercept at 3. And then our slope tells us to go down 1 and right 5. So down 1, right 5. Down 1, right 5. Or up 1, left 5. And there's our line. We could also do a table. You want to make sure that you choose numbers here that are actually divisible by 5. So every number here can be divided by 5. So if I do negative 10, negative times a negative is a positive, and 10 divided by 5 is 2. 2 plus 3 is 5. Negative times a negative is a positive. 5 divided by 5 is 1, and 1 plus 3 is 4. 0. 0, this whole thing will be 0, plus 3 is 3. 5 divided by a negative 5 is a negative 1, so 3 minus 1 is 2. 10 divided by negative 5 is negative 2, so 3 minus 2 is 1. Same points, you graph them. Problem 18, Julio is driving to the store. The average distance d in miles he travels over time is given by this function. So you don't have to make the function. They actually already gave you the function. What is the value of the function when t is equal to 15? So all we have to do is put the 15 where the t is. here. You can put it here and here. But here is where it's getting multiplied. So 15 times 0.5 will be 7.5 miles. So what is the value of the function when d is equal to 15? D, the function, is equal to 7.5 miles. That ends page 4. A statue of Rocky Balboa casts a shadow that is 16 feet long, and a 6-foot tall Christian casts a shadow that's 8 feet long. Which proportion can be solved to find the height of the pole? So, a statue of Rocky Balboa casts a shadow that is 16 feet long. Here it is, but we don't know how tall that statue is. Okay, so x over 16. This is the shadow. Christian is 6 foot tall. We actually do know how tall he is, but his shadow is 8 feet. So shadow with shadow and height with height. So when you cross multiply, you should get 8x and 6 times 16, or else we should say no. So yes on 8x and 6 and 16 together. So if you look here, is this 8x and 6 and 16? Yes. Is this 8x? No. Is this 8x and 6 and 16? 8x and 6 and 16? Yes. 8x? No. On number 20, the graph is showing Peter's distance from home. So here's home. And if we go up, we're walking away from home. And when we're coming back towards home, this is coming towards home. So how does the part of the graph labeled 1 compare with the part of the graph labeled 3? So in part 1, Peter is walking away from home. But in part 3, Peter is walking towards home. B. Describe what is happening on the part of the graph labeled 2. This means that he is taking a break, or he's not walking at all. He stopped somewhere, but time still keeps going. On problem number 21, we need to identify the dependent, the independent variable, and we need to write a function in function notation, and then we have to use the function to solve the problem. So a sanitation company charges $4 per bag. So you can see here $4 per bag for garbage pickup plus a $10 weekly fee, but that is not a variable, so plus $10. A restaurant has 14 bags of garbage, G. So we're going to put a G for garbage because they told us G for garbage, that goes in here, and G for garbage. So 4 times per garbage bag, so every garbage bag, plus the $10 for the weekly pickup. It's easier if you do the function first, because then you can see what the independent and dependent variables are. The independent variable is always the part on the right side, so G, which is the number of the garbage bags that we're using. And the left side, which is this whole thing, is the total cost of what's being charged. So that's our total cost. That's the dependent variable. Now, we're going to take that 14. We want to find out how much they're charging us for 14 bags. So we're going to put 14 where G is. And 14 bags times 4 plus 10 becomes $66. Part B is very similar. So Ali works in a shop and she works for 18 hours per hour. That's all they're telling us. There's no fee or extra adding anything. So our function is f of x equals 18x. So x is our independent variable, which stands for the earnings, the number of hours that she works. And her earnings is the dependent variable. That's how much money she's going to make. So earnings is the dependent and hours is the independent. And then they're telling us that how much money will she get if she only works 10 hours. So in the x, in the independent variable, we're going to put 10, and here also. So f of 10 equals 18 times 10, and 18 times 10 is $180. On part C, you can see that here the drone costs $300 plus $25 for each set of extra propellers. So the $25 for each extra set of propellers is the one that's repeating. So that's the one that goes with your X, plus the $300 that the drone costs. That's going to be our function. So the independent variable is the X, which is the amount of propellers, the number of propellers that he bought extra. And the f of x over here, that's our dependent variable. So that's how much money was spent, or total cost. Now they want us to find out what is the cost of a drone if he buys 4 extra propellers. So the 300 plus the 25 times every propeller, so 4 propellers. So that's 100 plus 300 is 400. That's the end of your review. I had an extra page here, and so I'm adding this, which is a little bit different than the one that you have, but it's the same idea. So on number 1 here, I have numbers that start with 3 and go lower than 3. So, but 3 is not part of it. So numbers that are lower than 3 are 2, 2, 1, 0, -1, -2, and so on. And numbers that are 3 or bigger are 3, 4, 5, and 6, for example. So -5 is going to be in this section here. So I'm going to plug it into that part. So -5 plus 2. So you can see here that I put the -5 here in place of the x. And -5 plus 2 is -3, and that's my first answer. For the second part, 3 will be in this part because that's where I have the 3. So I'm going to replace this x with the 3. So 3 plus 7 is 10. That's my second answer. Now 5 is going to be in this section here. So you can see that I'm going to replace that x with the 5. So 5 plus 7 is equal to 12. And that's my last part of the answer. If I was going to graph this, then I would use 2 tables. My first table is open. My second table is closed. And I would start at 3 for both of them. But for the first one, the numbers that are less than 3, so 2, 1. And for the other one, it would be numbers that are bigger than 3, so 3, 4, and 5. So if I substitute, I already did 5 here, so you can see that 5 was 12. And we already did 3 too, which was 10. And now I would just need to do 4, so, and that's in the second one here. So 4 plus 7 is 11. So that part's ready to be graphed. For this open part, if I plug in 3, 3 plus 2 will be 5. Here, 3 plus 2. And 2 plus 2 is 4. And 1 plus 2 is 3. So now I'm ready to graph. So what you would do is you would graph 3, 5, an open circle, and then 2, 4, and then 1, 3. And so the line would go this way. For the second part with the closed, it would be 3, 10, which is way up there. 5, 6, 7, 8, 9, 10. So it would be way up here somewhere. 3, 10. Then 4, 11. Oh boy. So I gotta move this. So I'm redoing this graph for you. So for the first part, 3, 5, open circle, 2, 4, 1, 3. So here, and the line goes this way. For the second graph, 3, 10, which is way up here, closed circle, and then 4, 11, which is a little higher, and then 5, 12, which is a little higher, so the graph goes that way. So that should help you with graphing. On part B, numbers that are smaller than -6 are -7, -8, -9. Numbers that are between -6 and 10 are -6, -5, -4, 0, 1, 2, 10. Okay, I'm just giving you examples, but it's going from -6 all the way to 10. And for x squared part, it's the numbers that are bigger than 10. So 10 are bigger, so 10. Actually, in this part here, the 10 doesn't count. So let's do something like all the way to 9. Okay, on the 10, it's 10, 11, 12. Just so you could get an idea of what numbers you're looking at here. So 0 would end up being in this section, and you can see that the y is always 5 there. So your answer would be 5. For -6, we're looking at this section again, and the answer again is 5. For number 10, that would be in this section here, and there it's x squared, so it would be 10 squared, which is the same as 10 times 10, which is 100. So my answer for that part is 100. Now I'm not going to graph that because you're not going to have graphing like this. So for j of x here, numbers that are smaller than 0 are -1, -2, -3. Here we're at equals 0, so only 0. And here x is bigger than 0, so that's 1, 2, 3, and so on. Okay, so if I'm at -25, then I'm going to be on the first one. So that's going to be -10 because I only have that one number. 1/2 will be numbers that are bigger than 0, so that'll be this one. So that's 10. And because the answer is 10 there. And for 0, it would be here. So the answer is 0. Easy. But graphing. For graphing, I need to do 3 tables. And the reason you're doing 3 tables is because you have 3 parts to it. So you can put the numbers that we put here, but the y is always going to be -10 for our first one. So it's always -10. Doesn't matter what your x value is. For the green one, which will be this section here, our y is always going to be 0. So, and actually you can only put 1 because there's only one point there, which is 0, 0. And for the blue one, we have our y being 10 all the time, and I'll put the same numbers I put there, 1, 2, and 3. So now for graphing, our graph is going to go from 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to -10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -10, and 10. So when I'm at -1 for the pink one, when I'm at -1, at 0 it's going to be -10. So open circle, and at 1, -1, it's -10. Oh, no. At 0, it's -10, open circle. At 1, -1, it's -10. At -2, it's -10. At 3, it's -10. So the line goes like this. Okay, for at 0, 0, it's only a green dot. So you only have 1 point. And at 10, for the blue, we're going 1, 10. At 0, 10. Close circle, oh excuse me, open circle, 10, 0, 10, and 1, 10, 2, 10, and 3, 10. So it's just a line going that direction. Okay, I'm skipping D. So on this part 2 here, they're asking me for -5. So 1, 2, 3, 4, 5, negative. And if I look at the graph, where am I? At 1. So -5, 1. So 1 is my answer. -5, 1. Now for the next part, which is now -1. So at -1, comma, -1, but there's no solution there, nothing. So I have to look at the other graph. So if we look at the other graph, part of the graph, so if I look at the other part of the graph, then I will see that at -1, I'm actually up here at 2. Now for 1, for part 1, at 1, if I look at the graph, I'm actually at 2 again. And you can see that because if I'm at 1, I'm up 2 right here. Now for part 7, 1, 2, 3, 4, 5, 6, 7, I'm here, which is 0. So that's where the graph is crossing, 0, 7, 0. So the answer would be 0. For actually writing the function, f of x equals, you have to do it in pieces. So the graph starts here. This is where I'm starting. So I need to figure out what my slope is starting here, going down 1, but I have to go right 2 before I cross again at a corner. So down 1, right 2, down 1, right 2, down 1, right 2. So that tells me that for this one, my m is down 1, right 2. Now, if I keep doing that, if I go down 1, right 2, then my graph is going to cross somewhere right here. Okay? My y-intercept is going to be here at -1.5. Means your b is at -1.5. So now I have my equation, which is -0.5 for half, x, minus 1.5 for the b. If my x's are starting here, less than -1, and not equal to because it's open, is less than -1. Now I need to go to the second part of my graph, which is here. So I start at -1 and go all the way to 3. So now if you see here, my line is a straight line, so that means it's just going to be a number, and the number is 1, 2, 2 here. So it's going to always be 2. If my x's are between and equal on both, between -1 and 3. For the last part, which is this one here, I need to find my slope again. So I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. So that means my m is equal to down 1, right 1, which is -1 because of the negative here. Now, if I keep going, if I do the opposite of that, instead of down 1, right 1, I'm going to go up 1, left 1, up 1, left 1, up 1, left 1. That means my graph will cross here. Now, if I look, what number will that be at? 1, 2, 3, 4, 5, 6, 7. So that means my b will be 7. Now I can do my equation. y equals m, which is -1, or just -x, plus 7 if my x's are bigger than, let's go look at what number. So this is where this one's starting. What is the x value here? 1, 2, 3. 3. If my x's are bigger than 3, but not equal to because it's open. So bigger than 3. If we look at -3, 1, 2, 3, and my number, and my graph comes up here. So 1, 2, 3. So 1, 2, 3 negative, up 1, 2, 3. At 4, 1, 2, 3, 4. This is open, so I have to move down here. So that's a negative 2. At 5. So on number 5, 1, 2, 3, 4, 5. The graph is up here at 1. Y equals 1. So we're going to write 1 here as the answer. And for negative 20, so for negative 20, if I go all the way to negative 20, I need to find out 1, 2, 3, 4, 5, 6, 7. It's okay if we don't finish that one. We'll cross that one out for now. They won't test you on that. Okay, that's the end of the video. Good luck on your test tomorrow.